All right, welcome. Thanks for everyone for coming. My name is Michael Park. I work at Facebook. I'm on the C++ libraries and standards team. This is pattern matching. We're going to be talking about a specific proposal that's already in committee today. So it's P1371. These are the co-authors of the paper. The latest status of the paper is that we talked about it in Kona on a Saturday session. It was generally well received, and we had great feedback. So the next thing is that we'll be taking it to Cologne in July, and we hope to discuss it further on a non-Saturday session with potentially more people. So I have two goals for this talk. There's two folds. One is to help you build intuition for how pattern matching works and how it can help you simplify your code. And second is for us to gather feedback. So ultimately, we want to deliver an awesome feature for C++. And so please ask questions and make comments as we go. If you see something and if it's like ambiguous or confusing or something like that, please make that comment so that we can address it. Or I'll tell you that it's not actually confusing or whatever. But let's make it a conversation, OK? All right, so before we even get into pattern matching, let me first ask the question, how many people are actually familiar with pattern matching in some other language, are extensively experienced in it? OK, so maybe we skip this whole section. I'll cover it anyway for maybe video or whatever. So before we get to pattern matching, there's two tasks that are extremely common, and they should be simple in programming that we do every day, right? One is selection, and the other is decomposition. By selection, I mean performing different actions based on some value. And so in this area, we have things like switch and if. And decomposition, we have some value. We want to retrieve components out of that value to take some action. And these are extremely common. We do this probably every 15 lines of code we write. So let's first talk about selection and status of it in C++. The first thing is switch, right? This is the first thing that you would reach for. And shortly after you start using it, of course, you realize that it's too limited. I think everyone probably has had this situation where you want to just switch on a string, and you can't do it because it only works for integrals. Actually, not even integrals. It works for a single integral, right? So even if you have just two integers, you can't just say like I want 0, 0. You have to nest switches to get what you want. So this is unfortunate. On the other side, we have if-else statements, which I think goes too far on the other direction. So here I have a simple expression tree. A classic expression tree with inheritance, and a very naive implementation of eval. So eval is probably not a good candidate to write this way. You should just write a virtual function. But an example of it would be something that's not applicable to your entire tree. So like, see if this subtree has value 42. You wouldn't want to infest your entire hierarchy with that. But let's take eval because it's a simple example. So what's the problem here? Somebody shout it out.
In middle return statement, minus.
This one here?
Yeah, it's for negation.
Yeah, that's for negation. Yeah, so sorry, let me describe the tree a little bit. So int is just the value, negation is performing negation on the expression, and then adding is adding two expressions.
It's both order and it's expensive to do dynamic casts.
Right, so dynamic cast is expensive. This is the biggest complaint, right? But in my opinion, honestly, it's not dynamic cast's fault. And the reason I say that is because let's say dynamic cast is just as expensive as a virtual function call, right? Then this being 3 times virtual function call is not dynamic cast's fault because it just doesn't have enough information, right? It's doing the best it can with what it has. The problem is really just that the if-else chain, this is not even an if-else chain actually, this is just like early returns and stuff. And it's very difficult for a compiler to look through a language construct that's this flexible and arbitrary and actually reason through that the dynamic cast can be consolidated. So inherently, what we're looking at is a structural association of these conditions and values. So if we look at the switch case, when we switch on a value and we have case C1 and C2, and let's say these C1 and C2 are arbitrarily complex expressions. Without expending C1 and C2, we can tell that C1 and C2 are used to compare against value, and there's an inherent association there. In the if-else chain with B1 and B2, without expanding and analyzing B1 and B2, what the Boolean is, we have no idea if it has anything to do with value at all, right? So it's a lot more work for the compiler. And so this is obviously not a new idea. This is principle of least power described by Tim Berners-Lee in 1998. Computer science in the 1960s and to 80s spent a lot of effort making languages that were as powerful as possible. Nowadays, we have to appreciate the reasons for picking not the most powerful solution, but the least powerful. And so an example of this, not in selection statements, but iteration statements, is the difference between range base 4 and while, right? With a while, you just have a Boolean expression, and so you have to place your iteration correctly in specific places to get what you want, whereas a range base 4 embeds your intent in the construct itself. You know what's happening without having to do any analysis. And so that enables compilers to perform vectorization, for example, as opposed to having to do more analysis for that. So the second half of this is, the reason for this is that the less powerful the language, the more you can do with the data stored in that language. If you write it in a simple declarative form, anyone can write a program to analyze it in many ways. And so often, the program that analyzing your program is the compiler, right? So oftentimes when you hear stuff like, oh, we can optimize better, that means there's more data in your program to leverage. In the case of switch, there are things that the compiler can do that can't do with an if. For example, if you have duplicate cases in a switch, the compiler can tell you. And that's inherently because there's more data stored in the restricted form of switch. As well as telling you that there are missing cases. Those have to be warnings, but for enums, you get missing cases, for example. And that's partially because of this inherent characteristic. So this is what I would describe as kind of the selection power spectrum in accounting for two factors. One is structure and the other is flexibility. And we have other options in the middle here, but there's a big gap, right? And so we mentioned virtual functions already. It's pretty structured in the sense that the derived implementations are still associated with the base class virtual functions, so there's some structural association there. But it's still not all that flexible because you can only use it for a single hierarchy. std_visit came along in C++ 17. Everything else is about 30 years old, right? So std_visit is also pretty structured in that you have a variant, you have a visitor that associated with the variant, but it's maybe more flexible in that it can handle multiple variants, but it still only works for variants. So I think that's where I would place it. And then we want to go here with pattern matching. We want to increase flexibility from a switch and virtual function and these kinds of things, and decrease flexibility from the if-else side to get more structure and our ability to reason about the code better. So let's talk about std_visit though, because it's an important candidate for us to get right. And the reason for it is std_visit has a bad. It's too complex basically. So this article it describes all of the mechanisms that you have to understand to use std_visit in a useful way. So in the standard way you use std_visit, you'd have to declare a function object before you actually call the std_visit, which is kind of backwards from how you would use a switch. Right? You want to say switch on this thing, and here are my cases. So having to say this cases ahead of time is a bit backwards. I realize this is a bit too small, but I'm going to read it out to you. This is a Slack conversation that I saw, that I caught at some point. There's a question of, at what point would you start considering std variant over a simple tagged union? And so the question was, I guess my main question would be, why are you avoiding variant? And the answer to that was the complexity of the interface. And the complexity of the interface really is just the std_visit interface it's talking about. So Michael's here. Michael Spencer comes along and he says, I would almost never go with variant because using it is painful, right? And as someone who was very much involved in the variant design and usefulness of it, I care about the usability of variant. And it makes me sad that variant is not being used because of std_visit. So how can we make it easier for variant to be used? Well, Michael says, when we get pattern matching, assuming it doesn't suck, then I'll start using variant. Okay, so again, questions and feedback so that we can make it not suck and we can make variant more useful. So the other half of this is decomposition, and also about this is that if you go back to the example of selection with this naive approach, The main point is that probably 90% of the time after you do selection, you're doing decomposition to get specific fields out that you want to do something with. And so my only point about decomposition is that it comes up all the time in conjunction with selection. So let's put these two together. What happens? So here's an example in Rust of nested select and decompose. So the enum here is kind of like a variant. So we have a message, we have quit, move, write, and change color. And then we can construct a instance of message of change color, and then we can match on that. So the matches appear here, right? It's pretty intuitive as to what's happening, right? You can guess as to what's happening here. So let me point out this axis here is the selection. And then horizontally, we're doing decomposition, right? We're doing that at the same time. Here's what you'd write in C++. Let's do the setup, quit, move, write, and change color, separate types. We pull it together with std variant. And then we would do a visit on an overload. And the overload is the thing that allows you to construct an overload set out of lambdas. I'm not going to cover it because it's kind of boring. But the point here is, again, we select vertically, and then we decompose horizontally, right? But it has to happen in two separate steps. And so this might not actually look too bad to you, but once we start doing more of them, right? So let's say that the change color command actually change a color enum, and so it could be RGB or HSV, right? So in this case, we match on message again, and we're just describing the value that we want to see, right? We want to change color of RGB, and then get the pieces out, right? We're selecting that way. We're decomposing that way because change color is actually stores a piece of data. We're selecting again, and then we're decomposing again, right? But the important part that I want to stress is that the value construction looks almost exactly the same as the pattern construction, and that's what makes it intuitive. So here's what we have to write in C++. The left-hand side is just the setup, getting the variant color, and then we have to visit overload on the message, which is this selection. We have to decompose, which is the change color.color. And then we have to select again within that, and then we have to decompose again, right? And so you can see how this increases nesting because you have to do each of these steps step by step. And so the takeaways for the motivation is that selection and decomposition are extremely common operations. We want a general selection mechanism between switch and if else. Selection and decomposition very often nest, and nested selection and decomposition leads to indentation, which I generally like to take the level of indentation as kind of level of program complexity. All right, so what is pattern matching? This is the quote from Haskell Wiki, so we know it's correct. It says, in pattern matching, we attempt to match values against patterns and, if so desired, bind variables to successful matches. So this information card here with the font and color will be available in the future slides so that you can keep track of what's happening. So here's an example. I don't know why I skipped that. Anyway, so here's a Rust example. We declare a simple point structure. We create an instance of point with 0 and 7. We can match on that point, and then the patterns are x, y equals 0, or x equals 0, y, or x and y. And so in this case, we would try to evaluate each pattern in order. And so the first one would not match because y is not 0. And then the second one would match because x is 0 and y can be anything. And then it would print y-axis is 7. Pretty simple, right? Everyone follow? No questions? Good. So in C++, we'd have to write something like this instead, where rather than describing our value, we would have to imperatively take our actions directly to get what we want. OK.
May I ask a question about the previous slide? In the second line, the initialization in parentheses, isn't that a C construct?
This one?
Yes.
Yeah, so the designated initialization was added in 2017?
20.
20, yeah. So you can do this now, which is kind of neat because it looks closer to Rust. Not a good design principle, but yeah. So yeah, that is allowed now. Okay, so in this view, pattern matching can be viewed as a declarative alternative to manually testing values with conditionals and extracting the desired components. Right, so those are the corresponding pieces that you would be replacing. So here's the pattern that we matched earlier. So in this case, there's two things that's happening, right? One is the test portion. We're testing for this point.x = 0 condition, and the other is the extract portion. And these two things are embedded in a single pattern. And that might remind you of something that happens in regular expressions, right? So if you have a regular expression like this, there are two things happening. One is testing for the string that we're looking for, and the other is the extracting of the portion that you want, which happens with the parentheses. So in this view, you can look at pattern matching as kind of a generalization of regex, right? And so this is just a summary of what patterns are all about. It matches and it binds. And the binding happens with getting access to pieces of the value that you matched, right? Pretty clear? Okay, so this is an example that we saw a few slides ago. And in terms of identifying where the patterns are and where the bindings are, the color should tell you where that is. And with our proposal, the proposal is to allow writing something like this, where you could inspect on a variant, and then very similarly describe the value that you want with a pattern. More complex example from before that required a lot of nesting. With the paper proposal, we would be able to just describe what we want out of the value like this. Okay. So the key idea here is that patterns and values are both built via composition. And so what I mean by that is the values that we build in C++, right, are built through composition, in that we have some integral, let's say, or literal, like 42. We might put that into a pair. That might go into a struct of some sort. And so we're building these patterns, we're building these values inside out. When we inspect them, we have to do that in reverse. And so we have to go outside in and peel these layers off by accessing .x and get 0 or what have you. And that's a lot of work compared to describing with patterns, where you can just partially build the value and then leave breadcrumbs along the way and say, like, oh, if you match this, I want this portion of it. And so the analogy that I like to make about this is that singing the alphabet forwards twice is a lot easier than singing it forward and then backward, right? And so the argument is that by allowing you to build patterns inside out the same way as values, I think we reduce our cognitive load by about half, let's say, maybe more than half. Okay, so starting from here is the details of the paper. We have 3 forms of pattern matching that we want to see. First is one that you've seen in previous slides, is a statement form. You can inspect on an X, and then you have different cases, and the pattern and the statement is delimited by colon. It's pretty natural, right? The next one is the expression form, where you can do an inspection on a value, and then you can use what we call it fat arrow. And then the thing on the right-hand side has to be an expression. And it has similar rules as, why did that flash on me? I don't know. Okay. It has similar rules as lambdas, where if you have multiple returns, they have to be the same type. And so in this case, they have to be the same type. Both of them are strings. Yeah, Michael?
Can you back one slide real quick?
Yeah.
Okay, you can go back. So there's no syntactic difference until you parse the entire thing to tell the difference between a expression and a statement.
Yes.
Is that an issue, or is it just like?
I think there was feedback specifically from David that he would want to see maybe parens instead of curlies to distinguish between statement versus expression before you get into the to individual cases. I think we'll need to do something there, but I'm not sure exactly what, because I think parens are a bit too subtle, and so, looking for ideas.
I think this is parsable. It's just complicated.
Is there a reason why you can't just have expression and have it and use it as an expression statement?
Just use it as an expression statement. You can use it as an expression statement, but the case that we want is for this thing to actually yield a value, right?
No, she's saying let it always be an expression.
Yeah, get rid of the previous one. I don't know what that does.
Oh, I see. So if we were to remove this,
No, you keep it, but it's an expression.
well,
Yeah.
Well, okay.
Read the syntax.
sure.
Yeah.
You can't do that and have a block scope and do multiple things there. That's why it can't always
Yeah.
be an expression.
You can have a lambda and execute. Well,
Yeah,
sure.
you don't need-
Sorry, I couldn't hear Zach.
I'm saying we can't have a block scope here and do multiple things if it's an expression, so we need both forms, right? You need to do different things than just return a value.
I see. Yeah. So Zach's comment is that statement would still be
So-
useful.
What's the separator between different patterns here? Is it just until you meet the next pattern? Is that the point?
Yes.
So you could put multiple statements there, but if
Yeah.
you-
Well, through compound statements. You would need
single
braces.
statement.
You would need braces to introduce a compound statement, and then you can have multiple statements. But it's still a single statement, right? So like a switch, the syntax for switch is just like switch, paren, expression, close paren, statement. And then the statement can expand to a compound statement, and then you need braces, and then you can have multiple statements in there. But the statement form is useful. Like if you're inside of a loop, for example, and you wanted to break or continue with the expression version, you couldn't do that. So that would be
You don't need braces in the switch. You can just have compound statements. Period.
Sorry.
You don't need braces inside.
No, you don't need it. It's just a statement which
you
can
have
expand.
multiple statements. You don't need. It's going basically till break of the next case because it uses case basically the next time you say case or default.
Michael, so that's the reason I use the term block scope and not compound statement, because you need a scope to introduce local variables.
I see. Okay.
Yeah, if you need all
Okay.
variables, you put braces. But
Okay.
You don't have to.
Yeah. So the comment is that we actually don't need the braces if we don't need block scope. So we might want to do something here to disambiguate early, but both forms are useful, I think. So in the cases where expressions can be different types, similar to lambdas, you would have to specify the return type of that thing, and so this is an additional piece of syntax that we would allow to consolidate to a single type, the resulting type. Yeah.
I have a question. Is it semicolon at the end of expression is limited?
Semicolon at the end of expression is what? Sorry.
It's obligatory.
Obligatory. Yeah.
And
This-
for the previous form, it was not.
Because it's a statement, the semicolon at the end is not needed for the statement form. Yeah, that's correct. Any other questions? Okay. The last thing that is actually not included in the paper, but we would like to think through is the declaration form. What kind of patterns would we actually allow in this initialization? So this is not allowed today, the nested structure bindings form, but we'll get into the thinking around what we would allow in here later. Okay, let's go through the overview of patterns. Disclaimer here: details subject to change in the revisions. It most likely will a lot of things will change because we have feedback that says we don't like some of the syntax and things like that. I kept the syntax in the paper as it were, but I marked them as red as kind of like contentious, asked to change, things like that. So primary patterns. So the wildcard pattern is surprisingly a very difficult problem, as simple as a job that it performs. So here it's double underscore. I hate it, but maybe question mark, something else, I don't know. But this is a placeholder for now. This is the placeholder that was used in P1110, which explored kind of how to do placeholders in general. We also proposed P1469, which was to disallow using underscore as the identifier inside structured bindings to try to preserve the use of that as wildcard in pattern matching. The feedback there was that we don't want underscore to mean different things in different contexts, essentially, was the feedback, because underscore is already used as as a placeholder for gmock and things like that to mean I don't care in various testing frameworks, right? So underscore. I mean, I don't even need to explain what it does, right? But the actual implications in C++ are pretty complicated. Anyway, it matches anything, gives you nothing, doesn't bind anything, but it'll always match. And you can nest those. Identifier pattern, this is also very complicated, but the semantics of it is that it'll match anything and bind the value that's being matched in that position and give it a name. And the rule here is exactly the same as structured bindings. So it's not a reference, it's an expression alias or whatever structured bindings does, which is a bit more than giving you a real reference. Okay, expression pattern, you can match against literals, and this here is to allow, the caret there is to allow arbitrary expressions as patterns. And so if you have, let's say 0 and 1 variables, in order for the right-hand side to mean the same thing as the left, you would have to put caret 0 and caret 1 in order for it to be referencing the previous variables as opposed to introducing new ones.
They would need to be compile time constant.
Yes. The question was, does it need to be compile time constants? The answer is yes.
Could you show previous slide?
Yes.
And what does x means?
Which x? This x?
The green x.
Yeah, so this is introducing a binding for the thing that it's matching, which in this case is value.
Oh, it's a variable name that's accessible in the expression on the right side.
Yes.
Is it like a structured binding, like just it's a magic alias for?
Yeah, the question is it like structured binding? Is it a magic alias? Yeah, it's just a magic alias. Okay, so let me go back. So here, if we have some value as a pattern, right? The question is, well, how does it match, right? Switch, for example, will do something very different than switch will ignore your equals, basically, right? So if you were to define an operator equal for your enum, and you use a switch with it, switch will not care about how your operator equal is defined. So how does this work? The one way to do it would be to do sequence of equals, which is the default. Now, if we were to do that, then what I suspect is that people will write types like this within here and give it an operator equal for int and within. And so the within here is intended to capture a range. So we take two values, first and last, 0 and 9, for example, and we're saying, I want this pattern to match if the integer that I'm looking at is between 0 to 9. Yeah, Michael?
Yeah, so you don't
Mickey?
have whatever you want to call it in other languages, where, or you don't have the ability to put an if in addition to the match. This is how you'd implement a where clause.
You can put the if afterwards as well. But if you wanted the condition to be in place for readability's sake, you could do something like this. So does everyone follow this example here?
Is match special? Like the name match is special?
Right, exactly. So the match function here is the thing that's going to be used to see if a pattern matches a value, right? If none exist, then we'll use equal. And the main idea is that we don't want incorrect equals for the sake of making this work, and so we can provide a match customization point. Yeah.
What do you think about providing a concept for one of these matchers?
Providing a concept for one of these matchers. Well, what purpose would it provide? Serve, rather?
I guess it would improve the specification here. Like, oh, if within happens to satisfy this particular matcher concept, then I'm using this.
Yeah. So the question is, would it make sense to add a concept for a matcher? And I think it's not very clear to me what the difference is between what we're doing now in terms of just requiring certain APIs and then collection of those APIs being a concept, right? Versus it being a real concept. So like the way structured bindings works, the way it requires tuple size, tuple element, and get, like you could look at it as a conceptual concept structured bindable concept or whatever, but it's not a real concept, right? And in this case, like if we introduce a real concept, it's not clear to me what the benefit would be, but conceptually I have no objection to the idea. I just don't know what the use cases would be. But maybe, yeah. Zach?
So it seems like there is, like as you said, there is an implicit concept here, which is that it has match, or otherwise I fail over to double equals, right?
Yes.
But it seems like where a concept could be handy is if I were somehow able to say in the inspect statement or expression, whichever, somehow introduce the name of a concept that said the thing that I wanted to pick up must be whatever. It might be match, it might be matches, it might be some other, right? But I can't imagine how a concept definition would help if we only had one way of doing a match.
Yeah. So the comment was that he doesn't see how the concept, or real concept, would be all that useful. Yeah, question?
Why not to use a functional object instead of such structure?
You mean the question is why use match as opposed to operator parens?
Yeah.
Yeah. There are other customization points, and so it's not clear to me that match is special enough for it to be operator parens. We'll get into the other customization points after. They're called extract and try extract. We'll get into those.
By customization point, you mean
Other functions that you can add here.
in
Yeah.
this class.
Right. Did you want to say something, Lisa?
No,
Okay.
In switch case statement, there is such a phenomenon as fall through.
Yes.
In this struct, is there anything similar to that?
So the question is, switch has fall through. Does inspect have fall through? Inspect has no fall through.
So it's always one branch only.
Yes. Yes. Did you want to say something? Yeah.
Yeah, how can match function be virtual?
Can match function be virtual?
Can we use polymorphic matches?
I have not thought about that. The question was, can the match be polymorphic? As specified, there's no reason for it not to be, but I don't know. But that's a good question. We should address that. Yeah. Yeah, Mickey?
Something you referenced earlier was like the ability of the compiler to tell you something is exhaustive. I mean, again, in other languages that have this, the matcher being an expression that the compiler could look through and see
Yes.
and tell your compilation.
Right.
Abros isn't exhaustive. Is good. So I think it's one of the concerns about making it virtual. Is the compiler can immediately go blah blah.
Yeah.
With
Yeah.
the-
Yeah. So the comment is that if we make it virtual, it would be even more difficult to optimize through this. And I agree. Yeah, it would hinder
It
optimization
might
for sure.
finally where context for virtual, because those rules are changing too. So when the
Right.
rules, right.
Yeah. Right. So yeah, optimization could be hindered. The only thing I'll say about it is that you're kind of opting into the difficult optimization cases, and if you want that, if you really need it, maybe I don't know. But yeah, we do need to address that. Okay. Any other questions? No. All right. Let's move forward. Super simple. Parenthesized patterns. No, it's not simple at all, actually. So parenthesized patterns is used just to group things. And so I have a silly example here, but the real example would be if you have multiple nested patterns and you wanted to group certain things, you could do that with parentheses. So the concept is simple, but there are parenthesized expressions, so it gets difficult just to use it as a general grouping mechanism.
How does that differ from just putting 0 there?
In the silly example?
In the first case,
Yeah, so the question is, how does 0 versus paren 0 differ? There's no difference.
And then in the second case?
No difference there either. These are just silly examples. But the real case would be if you have nested patterns and you want to group. Visual distinction of grouping of certain things inside nestings. David?
I think that it's true that you can always remove the parentheses, and it means the same thing.
The comment is David thinks that it's always true that you can always remove the parentheses and it means the same thing. I think my answer would be it depends how well we do with the associativity of the patterns. In expressions, because of those associativity of expressions, removing patterns changes meaning, right? And so with patterns, I think it depends how well we. We'd have to work through it basically. I haven't done that work myself. More interesting patterns. One is structured bindings pattern. So this is familiar with structured bindings if you've used that, and pretty self-explanatory, right? So you can use square brackets to introduce a set of patterns, and the observation here is that if you only have identifier patterns inside the square brackets, then you have exactly what structured bindings is. Yeah.
And when you say pattern there is recursive, so anything you've mentioned so far could be substituted for y, for example?
Yeah, the question is, are the patterns, so all of the patterns that I've mentioned so far, can they be replaced, mentioned inside the square brackets? And the answer is yes. Yeah. Okay, number two, oh.
Can multiple patterns be true?
Yes.
And the first one listed will be selected.
Yeah. So the question is the matching happening first in order of first match order versus best match. Multiple patterns can match, and the first one will win.
Because 0, matches all 4 of those, but it's the first one because it's clear first.
So in this particular case, the fourth pattern of x, y would match any value, but because 0, 0 comes first, that'll match first. Okay. So this is a cool one. This is the designated initializer syntax, but on the other side. And so if you have multiple fields in your product type, struct or whatever, and you wanted to, well, only struct, I guess. If you wanted to pull off only pieces of it and don't care about the other ones, then you can use the designated initializer syntax here to inspect parts of your struct, and not necessarily have to break apart all of it with square brackets, with structured bindings as they are today. Yeah.
Do you use a colon when you construct an instance of player here? Would you say dot hit points colon 1, or would you say dot hit points equals 1?
The question is, do you use colon when you construct the value? And the answer is no. During construction, it's equals. We considered equals here as well, but it seemed a bit odd because we're not actually assigning anything. So that's the reason for the syntax here. Yeah.
That begs a more general question, because one of the things you mentioned about pattern matching generally before was that you want the creation of the thing to look like the pattern matching
Yes.
the thing.
Right.
But you have to choose different tokens here.
Yeah.
Why is that? Like, maybe it's a subtle question, but like,
Yeah.
how do you make that trade-off?
Yeah, so I think ideally we want the values to look the same as the patterns, but we already don't have that. Like we can't, like structured bindings looks nothing like a tuple construction, right? And I think that the way the step that structured bindings took was that my interpretation of the direction that structured bindings went was that patterns operate on concepts, and so the square brackets pattern operates more so on product types as opposed to tuples or structs specifically. And so I think there's inherent necessary reason for patterns and values to differ. So yeah, that's kind of a roundabout answer, I guess. Any other questions on this? Yep.
If inside of the struct layer the hit points itself is a struct, then in patterns can I specify dot field, nested in a nested manner?
Sorry, so if you have a nested struct,
Yes.
so if like hit points was a struct, for example,
Yes.
then you would say dot hit points colon square brackets, and then whatever fields hit points has.
Not colon, but dot hit points, dot subfield, dot.
That's not supported as we've specified it. So the question is, can you say dot hit points dot x, let's say, if hit points was a pair of its? Yeah, so the suggestion was, or maybe not a suggestion, but the question was, can you say dot hit points dot x to get to the x field? And the question is, or the answer is, as we specified it, no, you have to say dot hit points colon square brackets dot x colon something close square bracket. Yeah.
We can work only with fields here, correct?
Sorry, say that again?
We can work only with fields. For example, can we run a method, some accessor method to check a field of player struct?
Oh, that's a good question. So the question was, can you only access the fields directly, or can you actually call an accessor method? As specified right now, you can't call an accessor method. But that's an interesting question.
One question is, does it check permissions? I mean, private, protected, etc.
Yes, yes. Same rules as structured bindings. Yeah, so structured bindings wouldn't let you bind to private fields, for example, unless you have visibility. Yeah, same rules apply, basically. Okay. This is the part where we want to make variants more useful, or maybe more usable. So this is the typical use case for variant, where you could use the angle brackets, specify the type that you want, and then you can recursively match the pattern of the thing that gets thing that's inside the variant. So simple example here is variant of int float. We're inspecting on that variant and then specifying int and float. And I would be an int and f would be a float. An important feature here is that it behaves similar to stdvisit. And so if you were to have a variant of int and you inspect with an int, both of those cases would dispatch to this one handler. Nikki?
And these, so if I wanted to say like int don't care, whatever you're calling your double underscore thing, does that work, or is that too special?
Int.
Whatever you're calling double.
So your question is.
All I know is that I got an int. I don't care to bind the int.
Yes, you can do that. So rather than, you can replace I with underscore underscore here to ignore the thing inside. Yeah. I don't know which one first.
Will it compile if you are trying to match type that is absent in the variant?
Type that
For
is
example,
absent.
In this situation, if we match floats, will it compile?
Yes. Well, there's more work to do there, but the topic there basically. So sorry, I need to repeat the question. So the question is, can if we were to add a handler for float here, would it work? And the answer is that it would work because usefulness is not enforced. And the reason for that is because if you were to let's say put this piece of code inside of a template, right? Then if you have handlers for int float string, then you could pass that thing variant of int string, and you have enough handlers, you should be able to handle that. And so that's kind of the motivation behind not necessarily enforcing usefulness.
And I'm not sure you could. We need other data structures because, for instance, let's say I have my own class that I derive from standard variant.
Mm-hmm.
You have nothing you necessarily can inspect to see what types it can handle, unless we would have to provide. Variant doesn't really provide that. We know it because that's how we designed the class. But
right.
In general, you would have to know.
Yes.
Type list somewhere to look at.
Yeah. So the comment is that we don't necessarily have all the information if it's not, in the case where it's not a specific variant where it gives you the type list. Yeah.
My question is, are the angle brackets there to disambiguate the grammar, or is it just to call, like, make it more stand out?
The angle brackets there is because we don't want int I where the I looks like a variable, because it's not. The I is just a binding, right? There's no instance of int like in this scope. And so that piece of syntax is partially for that. The other thing is that, as you'll see, we have polymorphic type support as well as any support for this. And so the inspiration for the syntax actually came from the fact that dynamic cast of T and then any cast of T, looks kind of like if you remove the dynamic cast and the any cast part of it, you end up with the angle brackets. Same with get if you were to think about it that way. Yeah.
Is there templates? I haven't thought through. Is there template support like auto or more importantly like concept maybe there?
Yes. So auto. This would behave similar to if you passed stdvisit a generic lambda, and then concept as well. So in this case, if you have auto, because you have integral, you would actually catch bool, char, and int earlier. Yep. Question. Wait. Sorry. Do you first second.
Can you remind how inspect part will be different in case if v is not variant, but if V is a union.
How would the
How
inspect
the
be
inspect
different?
Inspect part will be different in that case.
So the question is, how would the inspect part be different if we were matching against a union? And I don't. Well, so first of all, we don't support that because we don't know what the active member is. But you'd have to supply that through some other means. Right.
So you could match on the tag or something, and then you can find it. As long as that's close.
Sorry, one sec. Does that answer your question?
Union requires you to keep track of the tag, so
Yeah.
that's happening.
So
Either by reasoning it or storing it somewhere, some tag. So
Yeah.
Somebody provides.
yeah. So if you have an explicit tag, you could match on that and then access it or something like that. But yeah, Hannah,
Okay, how it will work with std and a concept.
how would it work with the
With std and a concept.
std any in a concept? That's not supported.
Oh.
Yeah. So the question was, how would this work with std any? It doesn't. Is the answer. So let me go back a little bit. This is the const expression case. So if we have variant int again, and you want to specify which one you want, you could actually specify the constant expressions to specify the index that you're actually looking for. Everyone okay with this so far? Good. All right, so next one is any, and any only supports type. So the way this would work is we would call any cast of int on %a, for example. And then if that matches, then we'll dereference the result and get the bind the I to it, etc. Yeah. Jim.
Is that a special language support, or is that for any, or does any provide some hook that tells it that that's the mechanism by which
So the question is this special language support, or is there some hook? The answer is that the modeling of this is kind of similar to structured bindings, where there's a priority list. So structured bindings will first look for tuple size, and then it'll try to do struct, and then it'll fall back to array. Maybe it's the other way around. But there's some priority list. And so the way we would do this is we first look for variant size, and then we look for any cast, and then we would fall back to polymorphic types. And so any cast in this case is a customization point.
Can you overload any cast for user defined types?
So that was a piece of feedback. So the question is, can you overload any cast for user-defined types? I think as today, it's not. Is it true?
You can specialize like anything in the standard library unless we say no.
Can you overload it though?
Unless you can't.
So as far as I understand, as far as I understand, overloading it is not allowed.
Right.
And so there was one of the feedback from Kona was, don't do that. And maybe we'll have to find a different, like separate customization point. And David is actually working on like better customization points in general for variants and any and things like that. So hopefully we can get something there. Any other questions? Let's go to the polymorphic type ones. So same syntax, but instead of any cast, we'd be using dynamic cast. So the check here would be is polymorphic, basically. And you can see the nested pattern here, right? We can match on the rectangle and then unpack it immediately with a structured bindings pattern. Yeah, Mickey?
So okay, sorry, I figured out my answer. So yeah, so this is statement form. So it's not that you're returning the result of this expression through some implicit.
Yeah. So this is a statement form. You could also write this in the expression form by saying return inspect shape and fat arrows.
And this is why it can't be an expression, as we said.
Right. Good. All right. So binding pattern. This is some of these are convenience patterns where. So in this case, we're saying identifier at pattern. The at is red because I don't think we'll get at because it's outside of the current character set. So we'll have to fix something else. But the idea here is that sometimes you want to match on something, but you still want the whole or the part that you were matching on. So if we were to have a variant of point and stuff, and we match on the point, and we break it up into x and y, on the right-hand side, you might actually want the entire point. Right? So rather than like having to put the point back together with the x and y, you would like to actually capture points separately. And so p on the right-hand side would be a point. X and y would be int or whatever. Yeah, question?
Look at the previous slide, please.
Yes.
So here, inside of inspect there are return statements.
Yes.
If we remove return keywords and use inspect in place of a ternary operator question mark colon, will that work?
Yeah, you could just do return, inspect, and put a semicolon.
So if I write inside of it int a equals inspect shape, and inside of inspect there are no return keywords.
And yeah,
Will that work?
so the question is, can this become an expression essentially? And the answer is yes, it can, but you need fat arrows instead of colons, and you remove the returns. So you would say int a equals inspect shape circle blah 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 arrow 3.34 3.14 blah blah blah, and that would work.
So it will require parentheses instead of curly braces. Is that what you mean?
Well, the curly braces and the paren is up for debate. But the thing that would syntactically change is the colon to equal greater than. That's the fat arrow thing we're talking about. Yeah, David?
And the semicolons become commas. Right.
And you'd have
And this, yeah, that's right. So the comment is the semicolons at the end of return would become commas, and then at the closed curly brace you would need a semicolon because the whole thing would be an expression. Make sense? Good. Okay, so everyone understand what the idea is here, where you want to potentially inspect but still keep a handle on the thing that you're inspecting? Okay. Yeah, so that's where it is. The dereference pattern, the star is also up for debate. There was comment or feedback that it was confusing. But I want to talk about the semantics of it rather than the syntax. So this is where the dereference pattern is. This is a silly example, by the way, so don't get tied up on the example. So let's say we have a silly a singular linked list. We have some value and a node and a next node. And we're going to inspect a node and say, if I have a value 0, and if the next exists and the value is 0, then I'm going to print 0, 0. Right? Silly example, but enough to demonstrate this point. So what that means is the star there is checked. And so the star pattern, the pattern will actually try to match if the thing that we're matching actually is valid.
That's so cool.
The comment was that's so cool.
So,
Question?
can you provide a bit more comments about the expression if next exists? You said if next exists.
Right. Yeah. So the question is, can I elaborate on the next part? So what I mean is the unique pointer next. If that is non-null, then we will dereference the unique pointer and match the next node with the pattern. So if next was null, then this pattern would not match at all.
Second value is after dereferencing next.
Correct.
Yes.
So the comment is the second value is after dereferencing next. That's correct. Yeah. Question.
Does much recursively?
Recursively? Do what recursively?
I mean traversal over the whole list.
Is the question, can you traverse through the whole list with this?
I don't know. It's just for next node or for all nodes?
This is so the question is just doing it for all nodes. This is only for the next node.
Oh.
Yeah. Everyone understand the semantics? Yeah.
What's the reason that it does the null check instead of just putting a pattern in yourself that says that it's, I guess, could you put a pattern that says it's not equal to 0 for a pointer?
But you don't even know the value.
But
Next is.
but you have so the question is, can you just check for a null yourself?
Yeah.
Is that the question?
Yeah.
Yeah, you could do that. You could do this in two separate patterns and say if it's null, then don't do anything, and then if it's not null, then dereference the thing and do stuff. But oftentimes you actually like making that sensitive. If you don't have the null check, then you're in UB land. Would actually be kind of usability wise might not be so good. So
If I
Zach?
want to check for just nullity, could I put stood null footer T or stood
it would be you would just put null footer there.
Okay.
Yeah. Anything else? Okay. All right, so this is the extractor pattern. We get to the extractor pattern. So there was a comment about match earlier. So this is where, this is the extensibility aspect of it. So the syntax is open paren, constant expression, bang, pattern, close paren, or you can do it with the question mark. So the matcher that we saw within only performs matching, right? It doesn't provide any bindings for you. And so if you wanted to actually create some bindings, you would need to go through one of these extractors to be able to create bindings into your value. So there are two variants. One is unchecked and the other one is checked. So the bang is unchecked and the question mark is checked. So let me go move on. So let's say we have some extractor E. And so if you say E bang P, where P is pattern, then you would match P against E dot extract value. Value is something that we're matching at the moment. E question mark P would say if auto result equals E dot try extract value. If that returns true, then dereference the result and match P against that. Zach?
Is the semantics of result like another magic alias?
Yes. Yes. Yeah. I'm only just showing the logic of stepping into it. Yeah. Oh, the question was, is the semantics of result a magic alias? Yes, it's a magic alias. Okay, so let's look at an example. So the dereference pattern that we saw could actually be implemented in terms of an extractor. So if you look at the deref struct here, we have an extract function that takes a value and returns star value, and try extract just returns the value that it got, right? So if we step through this, and then we can construct an instance of deref. So on the right hand side here, the value in the next example. If we say deref question mark, then we will say deref.tryExtract node, which will just return node. And then we'll see if the node is convertible to bool. And if it succeeds, then we're going to dereference that and match P on the other side. Right? Everyone follow? And so if you wanted to have an unchecked version of deref, then you could say deref bang, which would call extract, which would not do this conditional if null dereference check. Yeah.
Given that deref can be written as a library, why add special syntax for it?
So the motivation there was that given how prevalent pointers are in C++, we wanted to have nice syntax for, especially because pattern matching is going to be a useful case for inspecting trees. And most of the trees have pointers. And so that was the motivation, yeah, to make it a bit lighter on the syntactical load. Any other questions? I don't see that many frowns, so let's okay, let's move on. All right, so CTRE. Hana gave an amazing keynote 2 days ago. Let's see how CTRE could fit into this whole picture. So at the top here, I declared struct RE, which has a try extract function, which takes a string view, and I call CTRE match on it. And the result of CTRE match is just going to be my result. Okay. So we can create two of these, right? We can say RE of this regex, which is the number matching regex, and then another RE with date, which would give you the date matching regex. And then you can put it into an inspect and give it, use it as an extractor. So you can say number question mark, which would call number dot try extract of the string, which will then go through CTRE machinery, and then what will come out is a fixed size container of the matches.
Wow. I know, right?
The comment from Zach was, wow. I would like to capture that. So you can see that in the date case, you match, get the results out immediately. And this is something that you can't do with Sorry, did you
It's
say?
get better.
It's
Going to be better.
It's, yeah, so I was gonna say it'll get better. So yeah, this is something that I can't do with std regex because the results aren't fixed size, right? I just get a vector-like thing which I can't quite do this on.
Sorry.
All right, so if CTRE were to implement try extract inside this match, so CTRE match is actually an object, a context per object, and so with this API, if match were to implement try extract directly, then I don't even need my RE stuff, right? I could just say number is match of that thing, which would have the try extract API, and then I can throw it into the inspect, and it would do what you expect. And then you could even inline this whole thing, right? Just say match this thing and get the results out.
Do you need the parentheses here? Because of the
I think so.
question mark?
Yeah.
Yeah.
This is, yeah, so like I'm not a syntactical wizard, so I like did what I could with my within my abilities with some help, but I'm sure the experts can help with the syntax. Yeah, question?
Can you remind the meaning of the word whole here?
So CTRE match returns the first match is the full match. So
Because it gets capture. So the web expression always returns what was matched as the return capture 0.
\0.
So 0, 1, 2, 3.
yeah, so the whole is the first match of the regular expression, which is generally the entire match, as opposed to the captures that you specified.
You can represent with that.
Good? It's pretty cool, right? I like this example. Okay, so how many people were confused about the caret issue? Yeah, it's kind of weird, right? So I want to go into a bit of a design issue, this design space, and where like the decisions that we have to make, because the details, as I said, are subject to change, but there are design decisions we have to make as a whole, regardless. And so this is one of the areas. So the core problem is that identifiers are ambiguous. It's ambiguous where whether X here means an identifier pattern or if it means an identifier expression, right? And so there are several ways we can go about this. The approach that we took, obviously, as you see, was to disambiguate the expressions. And I'll give a reason why. But it's not an identifier-specific problem either, right? We can't just solve it for identifiers and move on, because even without identifiers, if I say 1 bar 2, in a lot of languages that means match 1 or 2. Whereas for us that means bitwise OR. And so if we were to add a pattern like this, then even without identifiers involved, we have ambiguities as to what it means. So other languages must have this problem too, right? So Rust and Swift both have this problem. This is a fun example actually. So Rust, let's look at the Rust example, right? So let x equals 1 bar 2. That means bitwise OR, so x is 3. We match on x, and we match on 1 bar 2. But the 1 bar 2 there is a pattern, it's not an expression. So it's not going to match that. We instead go to the otherwise case and we print otherwise. Okay? Swift took the other direction. So if we say let x equals 1 bar 2, that also means bitwise OR in Swift, that's 3. And then we say switch x on case 1 bar 2. The 1 bar 2 there is an expression. So now it matches. Right? So these are virtually the exact same piece of code that has maybe not opposite, but vastly different semantics. So what do we do? So these are the two implications, right? So for us, we said, well, we're inside of an inspect. We're doing pattern matching. So patterns should take precedence, was kind of the design decision that we made for this paper, at least. And I think it's a decent one. The other question is, do we want to allow arbitrary expressions? Like, how often do you want arbitrary expressions in your as your case? So if we disallow arbitrary expressions, then we're only left with disambiguating identifiers. And that's a smaller problem that we still have to solve, but it would be a smaller problem, right? So, but if we take Swift's, so if we go back, if we take Swift's direction, right, and say expressions that look, what are expressions today are still expressions in patterns, inside pattern matching, then what that means is we can't introduce new patterns that look like expressions, right? Like Swift can't, in the future, introduce 1bar2 as a pattern because that would break code, unless they don't care about backwards compatibility, but I think they do care about that. And so the fear there is that expressions take up a lot of the syntactical space, right? And so to give up that entire space for like any new patterns you want to come up with, you have to come up with new syntax. That's a real fear, right? And so this is the direction that we're in right now. So the caret symbol doesn't quite work because Microsoft something. So yeah, the question. Yeah, so there's a question.
Along those lines, it's interesting. You took a binary infix operator and made it a unary prefix operator. Why caret as opposed to double equal? Like, what did you consider? I'm curious.
So the question is, what did you consider as the ambiguation token? We considered things like equals. Yeah, we didn't really look at double equals. The caret comes from a language called Elixir, which is a successor to Erlang. It's kind of cute in the sense that the arrow or the caret is kind of like a lookup operator, where you say like if you say caret x, it means like the x is up there, look up.
I like the double equals because Scheme does it, and you're basically saying equal to this expression, but it looks weird, doesn't it?
I see. Yeah, yeah. The comment was that double equals is used in Scheme, and that's yeah, just as good. Did you want to say something, Lisa?
So I have, sort of my dream pattern set of patterns here, which maybe addresses this a little bit.
Okay.
I keep looking at this, and I really want a set of patterns that are parentheses less than expression, parentheses less than or equal expression, in close parentheses after the expression, parentheses double equal expression, and one for each of the relational operators. And
I see. Okay.
That would make, say, dividing a number up into ranges
Yeah.
so nice.
Right. Okay, so Lisa's comment is that a range pattern would be really cool, where you could say a pattern would be like less than 0, and that would be a pattern that matches if the value is less than 0.
Yeah. And you'd have to, I think you might have to put it in parentheses just to
right.
avoid hitting the type.
Yeah. So you might need patterns for syntactical reasons, but conceptually, she wants to say stuff like less than 0 to mean. So you could do that with the extractor stuff. You could implement it, but the actual comment was that if you had syntax like paren less than 0 close paren, then you could leverage that to say equal means what we want to mean here.
Mm-hmm.
So I think I understood that correctly, right?
Yes.
Okay, good. I think Mickey was first, and then
Yeah, so this is what I was asking earlier. I mean, the way that like a lot of functional languages handle this is like you can call it an if or a where clause, where you have like bindings, and then you'd say if x less than 0, or whatever bindings you had, right?
Right.
And that's how it's disambiguate in Scala. And I think
Yes.
that's the same thing.
Yeah.
So for all of that stuff, you would need the extractor or a matcher. With the downside of that being like, that you're back to the variant one from before, right? Where you you got to pull out. Okay, wait, what is this statement doing? You look somewhere else. Like it delocalizes it.
Right.
It's harder for compilers, it's harder for humans.
Yes.
In all ways, other than it's a crazy feature. It's harder for everybody else.
Mm-hmm. Yeah. So the comment is that a lot of languages allow what's typically referred to as pattern guards, where you can say pattern and then an if, or sometimes it's a when, and then you can put an arbitrary Boolean expression after that, where that entire thing would match if the pattern matches as well as the pattern guard matches. So that is also part of our paper. So syntax is pattern if Boolean expression, and I think that is the approach that a lot of languages take. So it's a valuable option also.
Why not?
So if you think about, I think the local So there's a locality of the code, but there's also locality of patterns. So consider, for example, if I say match tuple with pattern x, y, x. That's pretty clear what it means, right? If I say match pattern x, y, z if x equals z, like structurally it doesn't, I can't tell anymore. I have to reason through the Boolean expression again. And so I'm getting at the fact that like when you localize stuff that you mean inside the pattern, I think it's easier to visually inspect.
Yeah, you can do both, right? Like having the ability to say in the bindings these two have to be equal doesn't preclude you from saying x and x. Oh yeah, also over here I want to say that x is in some range, right? Like structural, like saying things that are purely structural should be in the pattern, unambiguous.
Okay.
Things that are not structural, rather relational, are outside of the pattern. Like adding a pattern guard doesn't preclude you from having structural matching.
Right. But, well, yeah. So as I said, pattern guards are part of the paper.
Yeah. So,
okay.
So I was just saying that. So the part I was asking is, why are you? So okay, so you have them, but you didn't show them. So you're not going. It's something you proposed, but aren't actually going forward with.
No, we are.
Okay. So
but yeah, it's going to be part of the proposal going forward as well. But David maybe wants to say something.
Just want to circle back to what Lisa was suggesting.
Okay.
One drawback of that approach is if you're inspecting and matching against your enumerators, like you inspect a enumeration value and you want to just have different cases for your different enumerators. For every single one of those cases, you have to put left parenthesis double equal the name of the enumerator, right parenthesis, which is a very heavy syntax for something which is really common. So the nice thing about the caret is you just put caret and then the enumerator.
Yeah. So David's comment was that the syntactical overhead of the paren relational operator identifier close paren or expression close paren would be pretty heavy syntax for common cases like matching on enumerators. Yeah. Okay. So let's see, some time. Let's do it. So the declaration form is an interesting area to kind of think through because we want this feature to be awesome, which means it should be cohesive through the language. So first we need to talk about refutability. What refutability means is a refutable pattern can fail to match for some value. So examples are literals, if you have literals inside compound patterns, or things like variants that would potentially not match, right? On the other hand, irrefutable patterns cannot fail to match for any value. So underscore is an example of that. ID expression or compound patterns that consist of only irrefutable patterns could remain irrefutable. So what does this mean? So we go back to this, right? This was the essence of patterns. It matches or binds, or it matches and binds. But refutable patterns match and bind, but irrefutable patterns actually don't match at all. It just binds stuff. And so that's the idea. And so if you're only binding stuff, then there's no potential for failure. And so the backporting of patterns to declaration form would be, today this is true, right? Auto irrefutable pattern equals expert. Our irrefutable patterns that exist today are ID expression, right? Or structured bindings, which only have irrefutable patterns, which are identifiers. And so obviously this is not how it's specified, but conceptually this is how we could think about how it works today and how it all fits together. And so at this point we have to ask, like, well, which of these patterns can actually go into structured bindings or go into variable declarations? And what we would say is that irrefutable patterns can go. And so it's things like extractor patterns or the field matching patterns, for example, we could backport. But this gives us a framework as to what's possible. The next question then is, can we allow refutable patterns in here, and what would that mean? So throw an exception would be one. Some languages do this. Scala, for example, will let you put refutable patterns into the variable declaration. If it doesn't match, it throws a no match exception. some other languages do that as well. In the case of Rust, Rust doesn't allow you to do put refutable patterns there at all. Another option would be to just make it UB, but I don't know. So I think in terms of like how it fits together with what's there today, I think irrefutable patterns work pretty well. So that's all I have so far. I'll go to questions, and if there aren't questions, I have some more stuff. Any questions? Yes.
So yeah, can you go back to you had a couple of those funky ones, like the the extractors, and then there was one other like extra go-go gadget strangeness.
Go-go gadget strangeness. Is it like over here?
Do you so do you reference pattern MRI with extractor? So yeah, okay. So for the extractor, for example, the extractor, for example, yeah. Let's go with this one.
Yeah.
Why, if you have guards, do you need this contraption?
Why through?
Why, if you have match guards, why do you need this contraption?
So think about how this example would be written with matchers. We would.
I'm saying, yeah. So you'd have dot zero, dot next. So you're saying, yeah. So you'd say what?
So let's say dot next colon next, and then we would say if.
Right.
And then the inspection of the stuff inside next. Like we wouldn't be able to leverage this pattern here, because we're inside the match guard or pattern guard land, and we can't like access the thing and then give it back to a pattern to get the power of patterns back.
Yeah.
Is that clear? Lisa?
Tell me if I'm wrong about this. With an extractor, you could say you could match against the last element of a linked list. By actually walking down, in the extractor you have code, you can walk to the end and hand it back.
Yes, you could do that. Yeah.
Yeah, yeah. So I guess that's back to earlier. So I mean, the way you would do that in a language that had more powerful structure bindings would be, you would just do you would have a variable structure binding. Like that, I know that's a whole nother can of worms that no one's in. But yeah, that's usually, you don't need this contraption in most languages because that problem is solved with something else. That's all I'm trying to get at. The problem I want to match against the last thing is solved by, you say like, whatever would be the syntax for star, don't care, and here's the last element I actually care about. So this binds to everything else. You match against the last guy.
I mean, that's true.
Do this last non-zero element or something.
Yeah. So the concept of extractors actually come from Scala.
Sure.
And so you could take a look maybe there for different perspective on extractors in other languages.
The other one was matcher. So what were the that was the other one. So yeah, extractors I'm okay with.
Okay.
Just got confused. And then,
so matcher was the within example.
Yeah. So
this one.
So for this one, this seems like this is where a guard makes sense.
Yeah. So it could. Yeah. I mean,
the reason why I like it better is just that localization, and then I like the fact that the compiler will warn you better, or at least it can. I mean, because
I'm not sure what it can do though, because it would have the exact same. I mean, you would just have this piece of code here. Like, how does that help the compiler?
Well, because the idea being, so in this case, you have the greedy thing under, right? So this will always be fine. Like there's nothing that doesn't match. But if you have something that's actually a closed range, right? Like here, you have to be the case that it's in, so it matches everything.
Mm-hmm.
But I could foresee again this being with enums or all the other kinds of things. Like by pulling it out, it makes it harder for the nice checks when it says, "Hey, this isn't exhaustive," right?
Yeah. So the comment is localization seems to take a hit here, and I the way I look at this honestly is like analogous to a function.
Yeah.
Like you can inline like describe your conditions every time, but if you have a common case that you have a lot, then you factor it out.
Sure.
Right. So in the similar sense, like maybe this particular example isn't a good one, but my point more so is that you can factor out common conditions that you're checking for. Rather than inlining them to every if pattern guard, you can factor it out. And
yeah.
That's
the concern is just that indirection makes it so like by allowing indirection, it makes it so that way you can't do the close thing. But you're saying fine, like if that's what you want, you give up the fact that the compiler can look into it and give you a warning.
Yeah, exactly.
You charge your own eventually.
Right.
C++.
Yeah, David, I'll get to you. He had his hand up for a while.
Did
Sorry.
you consider playing around with the ellipses so that you can match sequences and then bind them to spans?
Yeah. So.
I mean, just say no, but it's
Yes.
it's
No.
where you're going,
So the question is, did we consider ellipsis? So there's a proposal to extend structured bindings so that you can say like auto square bracket ... xs close bracket equals expr, where expr would be some tuple or whatever.
No, I mean like as a suffix where you match multiple instances of a pattern, and then if you have bindings.
Yeah, exactly. I'm getting there. So like in structured bindings, if you can say ... x's to mean repetition of the identifier pattern,
Okay.
right? Then you could say like this would be a next step, but you could say ... square bracket x comma y close square bracket, which would match like sequence of pairs,
Yeah.
right? And then like maybe x and y on the right hand side are like packs of matching the first elements of the pairs that came in, and y would be a second elements of the pairs that came in. And so like there is some interesting evolution there, but like on the surface of it, just allowing ... without a pattern involved would already be useful to ignore, if you just say x comma ... to mean I want the first value of a tuple, of a generic tuple inside of a template, for example, right? Which you can't do that with structured bindings today. David?
So going back to what's your name?
Mickey.
Okay, back to Mickey's comment. So one of the motivations for having this, I mean, we could just use the if thing afterwards, right?
Sure.
And put within 0, 9, and then you bind something here instead. If we didn't have this feature, and that's really largely an aesthetic issue, whether you're going to introduce a name there or not. Some people like it one way, some people like it the other way. But if we don't include this, people who like it this way are going to abuse double equals to make it so this works anyway. So,
Right.
So one of the thoughts behind including this in there is rather than having people abuse double equals, just go ahead and let people opt into it.
Yeah,
Yeah.
that's sensible.
Yeah. So David's comment was that the motivation for this matcher stuff is because otherwise, if we don't introduce it, then people will abuse double equals to get what they want. Yep.
So based on this example, my understanding is that this proposal proposes to introduce at least 2 new keywords, inspect and match. Is that right?
Match is not a keyword. Oh well, that's just a function name.
Then how inspect understands that exactly that function needs to be called?
So it's similar to so the question is how does inspect know to reach for match? The answer is it's similar to structured bindings where when you have a language feature that hooks into some specific API that it's going to call, like get.
Match is a magic function name. Also
Or like
extract is a
beginner
magic
That is
function.
already in the language as a magic keyword name. Is
It's
that
not
what
a
you
It's
said?
not a keyword.
No, it's not a keyword. So inspect would just try to call match.
But
Like-
begin and end and get.
Right, exactly. So it's like
are
begin
also
and end.
magic functions.
It's a compile time protocol.
Yeah, exactly. So it's like a range-based for loop where you have to opt in by specifying begin and end. Begin and end, there aren't like keywords or anything. The range-based for just knows to, hope that it's there and try. Right. Yeah, David?
When can we use this?
So it's targeted for C++. So the question is, when can we use this? So the feature is targeted for C++ 23. I think that as the proposal matures, hopefully we can allocate more resources to get a prototype. And then you could, play with it around in a Clang branch or something. Maybe on Gotbolt. That'll be cool. Yeah, question?
So, do you expect the performance to be similar to, handwritten or whatever? Because like variant doesn't allow you to specify, the policy how to generate the code for it. But here you can have, way more complex expression in the end.
Yeah. So the question is, what do you expect the performance to be like? The answer is if there are definitely more optimization opportunities. So for example, if you have a sequence of structured bindings, then you could actually do column-wise optimization to do switch over the columns rather than evaluating them in order. If you have stuff like this, where you have like custom code getting into your matching logic, then it more or less would revert to if-else chains. But a lot of so for example, the polymorphic type case, the Mach 7 library that Yuri, Bjarne, and Gabby worked on, they have a mechanism to like cache the results of dynamic cast to make that stuff faster. And that stuff is enabled by adding more structure to the analysis, right? And so I expect the polymorphic case to be much faster. And things like matching on integrals should be no slower than, or it should be exactly the same as switch. And so it's kind of a opt-in as you want kind of situation for optimizations. Any other questions? Yeah, David?
Why didn't the single underscore work?
Yeah, so the question is why did the single underscore not work? The answer is the single underscore is used in libraries today. So like Gmach has, what is it called? I forget the namespace name, but it's like testing : underscore. And so the way you use that is like try to expect that this function will be called with these arguments, and for this one I don't care. And so you'd put an underscore there. And so because it's a valid identifier name today, we would have to make it such that the underscore inside inspect has different meaning.
And so double underscore is reserved for implementation, so it's kind of less impact. We can there's less people we have to bother. It's hard. I mean,
and it's one. The other thing I would say is that it's one thing to make it context sensitive inside inspect, but when we start to think about the language as a whole, in the declaration form, like now auto underscore equals, like that can't be a context that we steal, right?
I can see why you don't like it though, because double underscore is almost as bad as like 2 white spaces.
Oh yeah, exactly. It's terrible. I had a silly idea though, where you can have 2 or more underscores and you can align things. Don't do it. Any other questions? I think I have.
So I guess hold on one time.
I think we have 2 minutes.
Just question back to you. Like, what was something that because you said you were trying to shop something, like what's a pattern or something you were trying to express that you couldn't figure out something for, just to throw it out to the world?
Sorry, could you repeat the question, please? Sorry.
It seems like you guys have thought through a lot of these things, but what was you said you're trying to shop around. So what's a pattern or a concept that you're trying to express here that you sort of haven't really been able to accomplish, or you're good, match everything you ever want?
I think so. The question is, what patterns did you want that you didn't quite get, or something like that?
Right? Yeah, you said you're trying to throw it
out. So the one thing that I'm still not so happy about is that the extractor stuff is very, very powerful because you essentially inject arbitrary booleans back into the structure. But what that means is that you don't have access to all of the patterns that are in scope. So in the CTRE example, for example, the CTRE match of number and date, doing those separately would be 2 separate runs of CTRE, as opposed to if you had access to all of those patterns, you could just create a single regex with a bar and then run it through CTRE once and then get your answer, right? And so we lose some optimization abilities across patterns, but enabling that would be crazy for library writers to account for that, right? And so we went for simplicity there and also allowing for power. But yeah, that's something that's kind of I don't know. I think it's okay, but maybe it could have been better, or maybe it could still be better. And the other one is the ... That would be really useful.
Yeah, that's on you guys, right? That's on structured bindings. I was waiting for to see it, but every time that's why I wasn't going to put it down. I never kind of kept going, oh yeah, we need that. Oh,
yeah, I think preferably all of it would be cohesive and move forward together. Sure. Yeah. I think I'm out of time. Thank you so much for coming.